Right. So first of all, let's start off with circumference, right? Which is going to be this little circle, right? All this white here. This outer line is their circumference, right? Their circumference is equal to 2 of pi times radius, or pi times diameter. Now, what does this mean? Well, if you draw a little line right to the very exact middle, this is the radius, right? But if you continue going with that little line, the entire segment is the diameter, right? Half of it's the radius, the whole thing's a diameter, which explains this, right? Because 2 times radius is 1 diameter, and from there you just multiply by pi, right? Next of all, she went over the following. Let me draw you a little circle first. If you cut this circle into this little bit, um, you get a couple pieces here, right? First of all, you get the radius actually, because this should be to the middle, so this will be your radius. Or this, either way doesn't really matter. And let me just flip through my notes real quick. I'm sorry. Right. You also get the arc length, which is this entire thing, because this right here is point B, and this right here is point A. So this entire thing is the arc length. And now this, I'm pretty sure, don't quote me, is the arc, with this being theta for, just an unknown degree measurement, because, it's degree measurement. Now, one thing I'm not too sure I missed whenever in class, I might have just put my head down for this, but these two parts actually have names, right? So this outer circle that's not in this little bit, this is the major arc. And this little circle here is the minor arc. So it's just important that we know our circle anatomy, of course. Moving on from that, we're also going to talk about a formula she gave us, right? That being the measurement of this line segment. Did I mention that? Sorry. This is a line segment, which I guess this would also be a point. The measurement of this line segment over 360 degrees, because there is of course, 360 degrees in a circle, right? Goes all the way around. Is equal to the arc length. The arc length of AB. Apologize, not very easy for mouse. So, and that's going to be over the circumference, which is 2 over pi r, or this. Now, what does that mean exactly? Well, the arc length of AB, meaning this portion of AB, is going to be over the circumference, right? And that should be equal to the measurement of AB. What does that mean? That just means this little measurement of theta here. Meaning, if, for example, you had, we'll do a little bit of practice here, right? If you had this circle, sorry. Now, let's say, well, we wanted to know this arc length here, right? Well, we'll say this is that's like a nice 40-degree angle. And this, well, we'll have our radius be, we'll say 4, right? This is going to make the equation look like this. The arc length, which we don't seem to know, do we? Because this is our arc length, but that's what we're solving for. The arc length over 2 pi radius, or, diameter pi, doesn't matter either way, but we're going to sneak this guy in here, right? Now that is going to equal to the measurement of AB. So this little arc here, which is 40. And that 40 is going to be over 360. Well, I mean, this is pretty simple from here, right? Because these are degrees, I'm assuming, you have to cross multiply. You can't just, algebra solve this. So you're going to multiply this by this. Hey, it's a new color, huh? You're gonna multiply those, and well, on one side we're just gonna get good old classic 360x, because you can't really, so you just stick them together until you can figure out what x is. Then once you've done that, you're gonna multiply these. So let's clear our history here. Don't peek. 6 times, whoa, where did I get 6 from? Am I right? 4 times 2 is 8. That's our diameter technically, but we don't talk about that. That times pi is times pi. That's going to be 25.13, right? But we'll round it to here. So it's going to be 25.1. Sorry, I think I made a mistake. So yes, this is 25.1. We're now going to multiply that by 40. Times times 40. So this will usually equal a very big number. In my very, very unfortunate tennis wheel example, it was like, or Ferris wheel, not tennis, sorry. Our Ferris wheel example, it was like, what, 17,000 or something insane like that? That's a big Ferris wheel. Point being, this is going to be 1005.3. Because, So we're just going to run to the 10th place. From here, you're just going to divide this entire thing by 360. Because we want to get rid of this, so we're going to divide our ants by 360. That's going to give us an answer of 2.7925. That's a lot of digits. I apologize if anything is too different on the screen. I lost a lot of recording because technical difficulties. Point being, this is a lot of digits, right? That is going to be rounded to a 2.8 because we're rounded to the 10th place. If it was to the nearest meter, or inches or foot or whatever we have this for, we'd round this to a 3. But since we don't really have anything to round that off, we're just gonna have that be that, right? Now, one other thing Miss kind of went over in class towards the end that admittedly I'm a little bit confused on. Maybe you can ask Kayla. I'm sure she knows. She's pretty smart too. A lot smarter than Neo, frankly. Point being, this, if you don't know this measurement, it was kind of odd because if it was just like, if you didn't know the diameter, I think it was just X. Like this was just X, right? You don't know X. But if it was radius, I think you had to put like 2X, which, makes sense. Or I think pi was in there. Like, pi X. So, just be aware of that this value is gonna, look a little odd. There might have been 2x pi. No, I think it was only, pi, x and something else, which x being diameter, radius. I'm sorry. The point being, that's really all I have for you guys today. Thank you, Mika, for watching, or I guess anybody else that tuned in, and thank you for your time.